Hi, welcome to our math. Today I'm doing a series of videos on graphing parabolas. This parabola is in vertex form. Vertex form, y equals x minus h squared plus k, tells you that the vertex is hk. Notice that part that's in the parentheses with x, you essentially have to set that equal to 0 to get the x value of your vertex. So what would make x minus 1 0? That would be a positive 1. And since the y and the k are already crossing an equal sign, you don't change that sign. 1, 4. So my vertex is 1, 4. From this vertex, I can get like just about everything else on this list. Axis of symmetry, x equals 1. The axis of symmetry is the x value of the vertex. Reflection point, we'll wait on that. Domain. The domain of all parabolas in math world is all real. Range. Well, this negative out front means that a is negative 1. If a is equal to negative 1, then we are going to have an upside down parabola, a frowny face, which means we're going to negative infinity, and we stop, range is your y values, at the y value of your vertex. It means our parabola is going to go this way. Increasing, decreasing, I'll do after I graph. Now, there are two ways to graph. The first way that I'm going to do with this one is I'm going to take a generic. I'm going to take y equals ax. Y equals negative 1 times x. And then I'm going to do a table of values. Negative 2, negative 1, 0, 1, 2. Let's see. And not this equation, this equation. Squared. Negative 2 squared is 4. 4 times negative 1 is negative 4. Negative 1 squared is 1. 1 times negative 1, 0, negative 1, negative 4. If we make our vertex our origin, then we can do this table of values from this point. Not from the origin, from the vertex. Negative 2, negative 4, negative 1, negative 1, 1, negative 1, 2, negative 4. Let's see what we get. We get our x-intercepts. Our x-intercepts are negative 1, 0, and 1, 2, 3, 3, 0. Our y-intercept is 0, 3. We are increasing up to the vertex, so we're increasing when x is less than 1 and decreasing when x is greater than 1. And then our reflection point is the fifth point. We've acknowledged the negative 1, the 0, 3, the vertex, and the 3, 0. This point is our reflection point. It's a reflection of the fifth point, so we have a 5-point graph. That's going to be 1, 2, 3. It's going to, usually we reflect the y-intercept, so the output should be the same as the y-intercept, just crossing the axis of symmetry. Had we done it the other way, if you are curious, if I wanted the x-intercepts, the natural way, x-intercepts are when y is 0. So when negative x minus 1 squared plus 4 equals 0. Well, we subtract 4 over. That happens when negative x minus 1 squared equals a negative 4, or x minus 1 squared equals a positive 4. We square root with a plus or minus. We get x minus 1 equals negative 2, or x minus 1 equals positive 2. We add 1, a lot. And we get that x is equal to negative 1 or 3, which is what we got originally anyway. Our original x-intercept was negative 1 or 3. As for the y-intercept, we get the y-intercept by setting x equal to 0. So we say y equals negative 0 minus 1 squared plus 4. Y equals negative times 1 plus 4, which is a 3. And that's what we have for our y-intercept, 0, 3. 0, 3. So we can do it either way. We can do it by the definition. We could do it by the pattern. Either way, we're getting the same graph. Doesn't really matter which way you approach the graph. If you do the graph first and get your information, if you do the information or get the graph second, you know, at the end of the day, if I look at the paper, I don't know which was written first. I hope you have enjoyed this video and learned something new. Subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks!